the sun and storms, an easy topic for discussion at present. For months, the sun has been showing its solar minimum trend, including numerous zero sunspot days and depressed solar flaring activity. Then, after the sunspots began appearing again in mid-August 2017, they surged to life as September turned and released numerous X-class solar flares and solar wind shockwaves called CMEs. These eruptions rank high for the solar cycle and on the historical records, and in their wake we have seen the Atlantic come alive to where on September 8, 2017, there are now 3 storms in the Atlantic basin on the heels of Hurricane Harvey's attack on Texas. Indeed, it was a lackluster Atlantic storm season until Gert in the middle of August. Then, as the month ended and September turned, we saw a surge in hurricane activity, including at least 3 major ones and Category 5 Irma, which surged to peak strength during the solar events. Looking more long-term at the sun, we have solar flares up top, then sunspot number, then proton radiation and cosmic rays at the bottom. Sunspot number second from the top is where we focus. The ramp up after extended quiet began in mid-August, just as Gert was churning, but it wasn't until the ramp up higher that we saw the extreme intensification of the Atlantic season, peaking so far this first week of September as the solar flares, sunspots, and geomagnetic storms peaked as well. Now, one season of temporal correlation is not a model or even a pattern. We need a longer time of examination. Luckily, this examination is ongoing. We've been at it a while, and what follows is our presentation of this material 2 years ago, along with updates from the interim time between.
And so let's take a look at what happens when the sun fires off and when the sun affects Earth in terms of the tropical activity. Well, you'll remember this from yesterday morning. The KP8, the level 4 geomagnetic storm of this summer, was followed just days later by 6 cyclones popping up in the Pacific. And that one just to the northeast of Hawaii did not hit the requisite strength to be classified in this way, or else it would have been the first time in recorded history of there being 7 in the Pacific. As I mentioned earlier, this was also the earliest example of 3 typhoons forming in the Western Pacific. Let's move on and take a look at some of the other things that have happened just this season. And these things are, and when I say this season, I mean this tropical season this year. The Northwest and the Central Pacific seasons are smashing record activity. They have sort of calmed down in the last few weeks, but as of late August, the records for activity in the Northwest and the Central Pacific were obliterated. We also have record super typhoon formation in the Northern Hemisphere just this summer. We had 4 tropical cyclones at once in just one section of the Pacific 2 different times. It happened in the Southwest Pacific, and actually the Indian Ocean was involved. Remember when all those cyclones were surrounding Australia? In the morning news I said they've got them surrounded. And it also happened in the Northwest Pacific as well. Hurricane Fred in the Atlantic is the easternmost tropical hurricane formation in the history of the Atlantic Ocean as far as we know. For the first time ever, we had 3 Category 4 hurricanes in the Central Pacific. And we had Hurricane Joaquin, which missed landfall by a good way and still managed to produce a 1,000-year flood in South Carolina at the same time that October Metacane, which is a Mediterranean hurricane, was pounding Italy, pounding France. And interestingly, all of these events match up with the space weather events that we've seen this summer. But rather than go and sort of look deeper at each one of these, I'm going to pick some specific extreme examples of space weather-induced activity. And before I do that, you see all of these records falling this year. And on this list, it's not even the occurrence of those 6 Pacific cyclones at one time. Any 1 or 2 of these things happening in a season really isn't that big of a deal. But when you get all of these things happening in one season, you kind of have to start to pay attention and say, wow, this season is not really what we're used to. And so You might ask the question, well, hey, isn't this the effect of global warming we're seeing? Or isn't this the effect of El Nino? This is the kind of thing we would expect. Well, if the tropical events were sort of just randomly dispersed across the time frame, you might be able to say, yes, this is global warming. Yes, this is El Nino. But when these things so clearly match a space weather-induced disaster scenario, you might want to start to think that maybe Earth's magnetic shield is not doing so well, and this is having effects on things that affect us like the weather. So, we had the 6 tropical cyclones in the Pacific. That was the KP8 in late June of 2015. October 1, remember we talked about this, the kill shot misses. That was when Hurricane Joaquin formed, and we had the Metacane over in the Mediterranean. In 2013, we had an X-class flare and magnetic crochet, very rare event. This is when the solar flare is so powerful that strong electric currents actually get surged through Earth's atmosphere. Now, this happens when the CME impacts Earth. The auroral electrojet starts firing up with the northern lights, and that induces currents. To have it from the flare itself is very rare. We call that a magnetic crochet. It hasn't happened but for a handful of examples. And just days later, we have Typhoon Haiyan. Now, when you talk about the typhoon records that are the big boys, you know, strongest storm, lowest pressure, fastest winds, largest area, every single one of those big time typhoon records are held by either Haiyan or Typhoon Tip, which occurred in October at the exact peak of sunspot activity back in 1979. And although we don't know what the flaring was like, we have some idea of what the auroras were like, we can say definitively that for the year 1979, statistically, the greatest chances for significant space weather occurred at the exact time Typhoon Tip formed. So, can you guys all see the timestamp down there? Is that sticking out to you guys at all? So we had very, very quiet space weather actually for days and days and days. And then, all of a sudden, the sun woke up like crazy. A ton of CMEs. Now, none of them were coming at Earth, but these were the type of tight, coiled CMEs that you often see really perturbing the inner heliosphere. And of course, this occurred, as I heard somebody say, exactly at the start of Hurricane Katrina. And it ended right about the time it hit its peak strength. The last time we had an X10 solar flare or higher was just a few days after that event that caused Katrina, and that was an X17. And the mid-month storm outbreak was the very last time before this summer that we had 5 Pacific cyclones at the exact same time, a very significant outbreak. The last time we had a near major solar flare was an X9 in 2006. We had the Hanukkah Eve cyclone strike Washington. If anybody's familiar with that, it was one of the strongest storms to ever hit the state of Washington. And to set a rain record in Seattle is no small feat, I have to tell you. Interestingly, that sort of very odd track that Hanukkah Eve storm took is very similar to Oho, which formed at the exact same time as Joaquin and the Metacane. And this is what Dr. Uyen mentioned, and it took a track that was very, very similar to the Hanukkah Eve storm. It hit the Canadian coastline a bit further north, but it's very interesting to see 2 very rare storms, and this late in the season, you don't see a Pacific hurricane swing up and go at BC like that, British Columbia, and we've seen it twice immediately after significant solar events. Hurricane Sandy. This was about the only solar uptick for about a month before or after Hurricane Sandy. And it just sort of came and went in the period of a week where out of nowhere we jumped up from B and C class flares up to M and X class solar flares, including a very large coronal mass ejection, which was not aimed at Earth, but as we've learned, they don't have to be aimed at Earth to perturb us. And that was, of course, when Hurricane Sandy sort of came up and did its thing, and it was the largest Atlantic storm ever by gale diameter. So, let's come back to this. And I was speculating that the melted power line and the electrical explosion just a few miles away in Washington state, along with the transformer fire in India, were very good candidates for space weather-induced disruptions on the ground. Now, wouldn't it be great if we didn't have to speculate, if the atmosphere could give us a hint, anything to tell us that, hey, wait a minute, yes, there is a disruption in that particular part of the world, Washington state and India. Well, Mumbai is where the transformer blew, is directly to the east of that cyclone that formed that day in the northwest Indian Ocean, and that was the tropical storm we just mentioned coming up towards British Columbia. Those were, at that time, two of the more significant tropical events on the planet, and just to the east of each of them is where we saw the best candidates for the space weather-induced activity. So both the melted power line and electrical explosion at the dam and the transformer fire in India occurred concurrent with the storm effects while these tropical storms, these atmospheric disturbances, were nearby. Here we go back with that coincidence thing again.
October 22nd, 2015, the week after this presentation. After a few weeks of low solar activity, we got a long-duration solar flare in CME. It arrived at Earth just 2 days later on October 24th, and within that short duration, Hurricane Patricia surged to become the strongest storm ever recorded on Earth, and the second strongest in terms of pressure intensity. The sun went silent for 1 week, and so did the Earth. Then, a set of M-class flares produced twin cyclones back-to-back that hit the Middle East in one of the rarest weather events in recent memory. Flare, storm, flare, storm. The next significant weather event came on January 11th, 2016, when Polly became the earliest Central Pacific cyclone formation on record, all while Alex was becoming a rare January hurricane in the Atlantic. After weeks of solar calm, an M-class solar flare the first week of the year was followed by a coronal hole stream impact and geomagnetic storm that lit up the skies over Finland on that very same January 11th. We waited a month for the sun to get active again, but it did so February 18th, just as auroras broke out across the polar region due to a coronal hole stream in the solar wind, and the sun kept firing. Within 24 hours of the solar uptick in Earth effects, Cyclone Winston became the strongest cyclone to make landfall in the recorded history of the South Pacific Basin. March was quiet. April was too, until out of nowhere an M6 solar flare erupted on April 18th, the largest of 2016, and caused a radio blackout at Earth. Within 24 hours, Cyclone Fantala was the strongest storm in the history of the Indian Ocean. That makes the strongest storm in the East Pacific, which is the strongest on record worldwide, the strongest to make landfall in the South Pacific, and the strongest in the Indian Ocean all since late October 2015, and the last two coming just here in 2016, and all during significant solar events. There were many more examples, including during the last level 4 geomagnetic storm in June 2015. Records fell for fastest paced and record-breaking storm seasons, and major storms occurred out of season and in unusual locations, all in the last 12 months. We saw this with major historical events as well. However, now it appears that Earth's weakening magnetic field is allowing weaker and weaker solar activity to disrupt our planet more and more often, to the point where the strongest storms on record are occurring at astonishing rates.